All right, so this lesson today is about trigonomic ratios, which this is the basis for all the trig that you will be doing in the future. So this is really important. It's going to take some memorization and then just some application. So our objective today is we'll be able to write trig ratios. We're going to be able to calculate trig ratios, and then we're going to be able to define the relationship between the sine and the cosine of complementary angles. So we've got 3 parts to our lesson today. Okay, this is your exit ticket. This is what you're going to be expected to do by the end of class. So you're going to be given a triangle and you need to find the sine of C, the cosine of C, and the tangent of C. You need to be able to calculate the sine of 84, and then you need to be able to answer this question about triangle LMN. All right, so we've been talking a lot about right triangles recently. We've been talking about the 30, 60, 90 right triangle and the 45, 45, 90 triangle. So now we're going to be dealing with any right triangle, okay? So I always have the 3 pieces. I know this is a leg, and this is a leg, and this is a hypotenuse, because here's my right angle. And then the same is true over here. So we're going to be talking about the idea of a reference angle. So the reference angle is just the angle that we're talking about. So it's this angle right here or this angle right here. And your reference angle will always be given to you, so you'll know what that is. So in terms of the reference angle, the side opposite, we've been dealing a lot with that with the 45, 45, 90 and the 30, 60, 90. So if my reference angle is here, this is my side opposite. If my reference angle is here, this is my side opposite, okay? The hypotenuse stays the same no matter where my reference angle is, because the hypotenuse is always across from that right angle. All right, so we're good with the opposite. Now with my reference angle, the other leg is called the adjacent leg, because adjacent means next to. So the reference angle is always made up of the hypotenuse and the adjacent leg. So those two make up the reference angle. So same up here. Here's my reference angle. Here's my side opposite, this is my hypotenuse, and so the other leg is the adjacent side, the one that touches the reference angle, okay? So make sure that you're familiar and understand and can identify which side is opposite, which side is adjacent, and which side is the hypotenuse. All right, so these are the basic trig functions that we're going to be working with. So we have sine, cosine, and tangent, and we shorten them to, you'll see sin for sine, cos for cosine, and tan for tangent. So when we see those, you'll see on your calculator, those are there. That's what they stand for. We're going to be dealing with this SOHCAHTOA. So SOHCAHTOA is just a mnemonic device that we use to memorize what goes with what. So if you notice, S for sine, is opposite over hypotenuse. So that's the so. So memorizing that when I see sine, it's opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that's where SOHCAHTOA comes from. It's just an easy way to remember what goes with what. So sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. And that's just a process of memorizing what goes with what. All right, so as I'm asked to write trig ratios or set them up, I have a thinking process that I go through. So the first question I always ask myself is, where is my reference angle? So we talked about that's the angle that's given, so that's my starting point. That's where I'm going from. Then I need to identify from that reference angle, where is the opposite side, the adjacent side, and the hypotenuse. The next question is, what am I looking for, sine, cosine, or tangent? Then which trig ratio is associated with that? So if I'm looking for sine, then the trig ratio would be opposite over hypotenuse. If I'm looking for cosine, it'd be adjacent over hypotenuse. And if I'm looking for tangent, it'd be opposite over adjacent. Then what fraction can I write? So I'm just going to use that reference angle to write my fraction, and then can I simplify it? So that's the process we're going to be going through. All right, so in the first one, I want to know what are the sine, cosine, and tangent for angle T. So the first question I'm always asking is, where is my reference angle? So angle T is my reference angle. Okay, so I'm talking about from angle T. So then I need to ask myself, where is the opposite side, the adjacent side, and the hypotenuse? And I want you to always label these. So obviously from angle T, 8 is my opposite side, so I'm just going to put an O. 15 is my adjacent side because the opposite side is always the leg across, so the other leg that touches the angle, my reference angle, is adjacent. And then we always know that the hypotenuse is across from the right angle. All right? So once I've labeled my triangle from my reference angle, am I looking for sine, cosine, or tangent? So in this case, I'm looking for all three. So I'm going to just start with the sine. All right, so the sine of t is what trig ratio is associated with sine. Okay, so sine is SOH, which is opposite over hypotenuse, so SOH, so, and then cosine is adjacent over hypotenuse, so that's the CAH, so CA, and then tangent is opposite over adjacent, TOA. All right, so this is where that memorization comes in. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. All right, so which trig ratio is associated? We're talking about opposite over hypotenuse. So what fraction do I write? Well, I literally just take what is the side opposite, so that's 8, over what is the side, the hypotenuse, well, that's 17. So that's the sine. That's it. All right, so then what is the cosine? So I'm going to say the cosine of t is, and which trig ratio is associated with that? Well, we already said that cosine is adjacent over hypotenuse. So which side is adjacent to my reference angle, t? It's 15. And what's my hypotenuse? It's 17. All right, so that's the cosine. And now the tangent. So the tangent of t, and I always want to put my reference angle in there because I could be talking, I want to make sure we're not talking about g, we're talking about t. So the tangent of t, which trig ratio is associated with tangent? Well, it's opposite over adjacent. So from t, what side is opposite? Well, that's the 8. And what side is adjacent? That's the 15. So my sine is 8 over 17. My cosine is 15 over 17, and my tangent is 8 over 15. So that's how we do those basic trig ratios. So go ahead and try number 2. See if you can find the sine, cosine, and tangent for angle P. Alright, so for number 2, you should have gotten the sine of P is 15 over 17. The cosine of P is 8 over 17, and then the tangent of P is 15 over 8. If you got that, you can go ahead and skip to the next slide. If you didn't, I'll explain it now. All right, so the first question is always, what is my reference angle? So when I look at this, my reference angle is P. All right, so then once I've identified where my reference angle is, then I'm going to ask myself what side is opposite, adjacent, and the hypotenuse. So the side opposite of P is going to be that 15. The side adjacent is 8, and the hypotenuse is 17. So those are my the labels for my sides. So then I'm asking, what is the trig ratio associated with the sine? Okay, sine is always opposite over hypotenuse. So when I said the sine of P is the side opposite over the hypotenuse. So opposite is 15, hypotenuse is 17. So 15 over 17. All right, which trig ratio is associated with cosine? Well, cosine is adjacent over hypotenuse. So adjacent over hypotenuse is going to be 8 over 17. My side adjacent and my hypotenuse, so 8 over 17. And then tangent is always opposite over adjacent. So from side P, opposite is 15, adjacent is 8. I'm sorry, from angle P, not side P. So that's how I got those trig functions. All right, so for 3, 4, 5, and 6, it's pretty much the same thing. I'm going to be using the exact same figure, though, to answer them. So we have to pay attention to what's my reference angle and which trig function am I using. All right, so when I look at number 3, I'm going to go through those same questions. So where is my reference angle? So it's asking for the cosine of D. So D is my reference angle. Where is the side opposite, adjacent, and hypotenuse for D? All right, so 16 is going to be opposite, 8 is going to be adjacent, and 18 will be the hypotenuse for angle D. All right, then I'm looking for the cosine. So which am I looking for? Cosine. Which trig ratio is associated with cosine? All right, cosine is adjacent over hypotenuse. And again, it's just memorization. You just have to be familiar with those. All right, so if it's adjacent over hypotenuse, well, when I look at from my reference angle D, the adjacent side is 8 and the hypotenuse is 18. So that's going to be 8 over 18. All right, and then my last question is, can it be simplified? And I see that 2 can go into both of those, and I end up with 4 over 9. So the cosine of D is 4 over 9. All right, so looking at number 4, where's my reference angle? So I'm looking for the sine of F. So F is now my reference angle. Where is the opposite side, the adjacent side, and the hypotenuse? So 8 will be opposite, 16 will now be adjacent, and 18 is the hypotenuse. All right, which trig function am I using? So I'm talking about the sine, and what ratio is associated with the sine? Well, the sine is opposite over hypotenuse. All right, what fraction can I write? So the opposite of F is 8, and the hypotenuse of F is 18. So this is 8 over 18. And can I simplify it? Well, I see that 2 goes into both of those. So I get 4 over 9 as well. So that's interesting that the cosine of D is the same as the sine of F. So I want you to think about that. Why do you think that those are the same? That the cosine of D is the same ratio as the sine of F. We're going to come back to that. All right, so number 5, I'm looking for the tangent of D. So what is my reference angle? D is my reference angle. Where is the opposite, adjacent, and hypotenuse? 16 is the opposite, 8 is the adjacent, and 18 is the hypotenuse from my reference angle D. Which trig function am I looking for? Well, I'm looking for the tangent. What ratio goes with tangent? Okay, tangent is opposite over adjacent. So what fraction can I write? Well, my opposite side is 16, and my adjacent side is 8. And can I simplify? I can. I can simplify that to 2. And lastly, what is my reference angle? Okay, my reference angle is again going to be F. So from F, what side is opposite, what side is adjacent, and what side is the hypotenuse? So I've got those. And then which trig function am I doing? So I'm using cosine. And what is the ratio associated with cosine? It's adjacent over hypotenuse. All right, so what side is adjacent? Well, I've got 16. And what side is the hypotenuse? That's 18. So what fraction can I write? It's 16 over 18. And can I simplify it? Well, I know 2 goes into both of those. So 2 into 16 is 8, and 2 into 18 is 9. So that simplifies to 8 over 9. All right, so going back to our objective, we had 3 parts to it, that we could write trig ratios, calculate them, and then talk about the relationship between sine and cosine of complementary. So we have just learned how to write trig ratios. So using that SOHCAHTOA, I can take a right triangle and I can write the ratios associated with that. So let's move on to calculating. All right, so the sine, cosine, and tangent are always being taken of an angle. So I'll always look for the sine of 34 degrees or the cosine of 67 degrees, okay? If you're given any angle measure, you can use your calculator to find that trig ratio instead of having to write that fraction out. A big, huge thing is before you begin, we always want to go to the mode button and make sure that we're talking about degrees because we're talking about angles. Radians is something that you'll get into a little bit in Algebra 2, but a lot into pre-cal. But right now we're going to live in the world of degrees. So when I put in 60, that means 60 degrees. So go to your mode button and make sure that you're in degrees. I would highly suggest that when you go to take an important test like a module test or a TN Ready test or our final, that you always start the test by clicking in mode and making sure it's in degree mode. Alright, calculating is very easy. There are 3 buttons on the calculator, sine, cosine, and tangent. You're going to push whichever one you're looking for, and then you're going to enter your angle measure and hit enter. So for instance, if I'm looking for the sine of 30, I'd hit sine 30 and enter. And that gives me my trig function, or my trig ratio. It's 0.5, which would be 1/2. The tangent of a degree 26.57 is going to be 0.50010, and I would round appropriately. Okay, this is pretty straightforward. So I need to calculate the following values using my calculator, round to the nearest 10,000th, so we're talking 4 decimal places. So literally I'm going to take my calculator, I'm going to hit mode to make sure that I'm in degrees, and I'm going to literally type in the sine of 80, so sine 80, and hit enter, and I get 0.9848, so it's almost 1. Alright, the cosine of 41, so literally in your calculator you're going to type in cosine 41 and enter, and I get 0.7547. And that is how you do this. So go ahead and find the tangent of 27, the cosine of 35, the tangent of 12, and the sine of 77. Go ahead and complete these problems. Alright, so you should have gotten the appropriate values, so go ahead and check your work and see how you did. Alright, so that was the second part of our objective, to be able to calculate trig ratios on the calculator. Pretty straightforward and easy. So now we're going to move into the last portion of our objective. Alright, just a little review of some terminology from Module 1. Complementary angles. So we have supplementary and complementary. We know supplementary means they add up to be 180, and here we're dealing with complementary. So complementary is always 2 angles whose sum is 90 degrees. So because we're dealing with right triangles, the other 2 angles in the triangle are always complementary. I want you to think about why. So go ahead and think about this right triangle right here, because we're dealing with right triangles. The other 2 angles in the triangle are always complementary. See if you can come up with a reason why. Alright, so I wanted to talk about the sum of the angles in a triangle is 180 degrees. So x plus y plus my right angle, which I know is 90, is 180. So if I think about subtracting this 90 from both sides, the one that I know, I end up with x plus y is equal to 90. So right there I've just proved why they're complementary, because the 2 angles that are not the right angle have to add up to be that other 90 degrees. Alright, so what I want you to do is I want you to take these 3 examples and I want you to find the sine of A and the cosine of C. So what we're talking about is we're finding the sine of one angle and then the cosine of its complement. So here the sine of A and then the cosine of C, the sine of A and the cosine of C, and let's see what we notice. So I'll do the first one. So the sine of A, well, I look up here and I see A is right here and A is 70 degrees. So I'm actually looking for the sine of 70. I'm going to type that into my calculator because I'm given that angle value. So I can say sine of 70 and I get 0.9397. Okay, and then I'm going to find the cosine of C. So when I look at this here, C, the cosine is 20. So I'm actually typing in my calculator cosine of 20. So what I want you to do is go ahead and find the cosine of C here, and then go ahead and complete these other 4 problems and see if you can come to a conclusion about the sine and the cosine of complementary angles. So complementary would be, if I'm given a right angle, the other two automatically have to be complementary because they have to be at 90 degrees. All right, so what you should have gotten is that the cosine of 20 is that. Here's the sine of 54 and the cosine of 36, the sine of 66 and the cosine of 24. And when I look at this, 70 and 20 are complementary because they're 90 degrees. 54 and 36 are complementary because they make 90 degrees, and 66 and 24 are complementary because they make 90 degrees, which makes each of these a 180-degree triangle. And what you should have noticed is that the sine of one angle and the cosine of its complementary angle, so the other angle, are equal. So we can say they are always equal. Okay? And I want you to think about why. Why do you think that they will always be equal? And go ahead and let's just go back to our basic right triangle that we talked about. I'm just going to make up some sides. Let's say this is 2 and 6 and 8. Okay? And I want you to think about if this is my angle A and this is my angle C. Okay? I want you to think about, why would the sine of A be the same or equal to the cosine of C? So play around with that and see what you find out. So what you should have discovered is if I use actual values, I know sine is opposite over hypotenuse. So when I look at the sine of A, I'm going to use 2 over 8. Okay? Well, the cosine of C, cosine is adjacent over hypotenuse. So the side opposite of A will always be the same as the adjacent side to C. And so that ended up being 2 over 8 as well. So the sine of A, using the opposite, the side opposite of A is always going to be adjacent to C. If that's confusing to you, I don't want you to worry about the reason why right now, but I just want you to know that they are always equal. So the sine of one angle will always be equal to the cosine of its complementary angle. So let's apply that. All right, if the sine of 30 is 1/2, what is the cosine of 60? So I'm just going to draw myself a little sketch here. All right, so if this is 30, that would make this 60. Okay, it's saying the sine of 30 is 1/2. So sine is opposite over hypotenuse. So that would be 1 over 2. So the cosine of 60, so cosine is adjacent over hypotenuse. So it's going to be 1 over 2 as well. So the cosine of 60 is 1/2. And the reason, so my justification, and this is a piece that has to be in your test. You're going to have a test question like this, and I need to see these pieces. First of all, I need the answer. So the cosine of 60 is 1/2. And the reason that I know that is because I'm going to talk about them being complements. So I'm going to say 30 plus 60 is 90. So I'm showing that they're complementary angles, first of all. And then I'm going to say what we talked about before. And the sine and cosine of complementary angles are always equal. You could also use your drawing as evidence and talk about the sine of 30 is 1 over 2 in my drawing, and so cosine is going to be adjacent over hypotenuse. So you could also talk about your drawing. All right? So go ahead and try number 2. Come up with what the sine of 17 would be and your justification. All right, so I said that the sine of 17 will also be 0.29 because 17 plus 73 is 90, and the sine and cosine of complementary angles are always congruent. So the pieces of this answer that would make it complete are just what is the sine of 17, or what's the answer, talking about proving that those two angles are complements, and then saying that the sine and cosine of complementary angles are always equal. So there's 3 parts to this answer. All right, so number 3, in triangle ABC, angle B is a right angle. So I'm just going to go ahead and I'm going to draw a picture. And it says B is my right angle. So I'm going to say A and C. All right, so it's asking me what is the relationship between the sine of A and the cosine of C. All right, well, what we just talked about, I know that the sine of one angle is going to be equal to the cosine of its complement. So that's it. That's the relationship. They are equal. Will this relationship be true in all right triangles? Why or why not? So, will it always be true? Will it always be true that the sine of one angle is equal to the cosine of its complement? And yes, it will always be true. And why or why not? All right, so my justification is because one angle in a right triangle is always 90 degrees. So I always have a 90-degree angle in that right triangle. So that means that the other 2 angles have to be complementary as well, because they have to add up to 90 to get the 180 that every triangle is made up of. And I know that by proving that they're complementary, I know that the sine and cosine of complementary angles are equal. So it will always be true because the other 2 angles of a right triangle always have to be complementary. So they always have to be 90 degrees. All right, and lastly, if the cosine of A is 11 over 12, what is the sine of C? So going back to my reference angle, or triangle, so the cosine of A, what is the sine of C? So go ahead and try and answer that. So my answer is the sine of C will also be 11 over 12, because if I think about A and C, in this case they're complementary, and the sine of one angle is always equal to the cosine of the other angle. So if the cosine of A is 11 over 12, then its complement C, the sine of that will also be 11 over 12.